Welcome back. I will be discussing applications of the linear function, or the linear models. That means I'm going to give a problem, real life problem or situation, and then we will turn that to a mathematical model. At this time, we're going to use the linear function as a model. For example, the population of a city increased from 23,400 to 27,800 between 2008 and 2012. Find the change of population per year if we assume the change was constant from 2008 to 2012. And then at the same time, we will find also the model of this problem. Okay? So for example, population, we will say X is the year and Y is the population. So we have 2008 as 0 and we have 23,400, and then we have 2012 as 4 years after, and then we have 27,800. It increased. So that means my M, Y is equal to MX plus B. My M would be positive because it increased. The population of the city increased. So M is equal to 23,400 minus 27,800 divided by 0 minus 4. Then we have 0, 0, 4, 400, and then 4,400 divided by, that's negative, negative 4. That means our slope is 1,100 persons per year. So our model now is that we have Y is equal to 1100x plus B. I will use this point. So we have 23,400 is equal to 11,000. 1100 times 0 plus B. So this is 0. So my B is 23,400. That means Y is equal to 1100x plus 400. Do you remember the domain and range? So my domain here now is X is greater than or equal to 0. I cannot have X as a negative. Time is never be negative. And range, we have Y is greater or equal to 23,400. It cannot be infinity. That cannot be that one because maybe that city cannot hold as much as possible. So at this time, I cannot guarantee that it is always greater than 23,400. It might be that it will be less than also. But as of this, in this model that we have, that is what we get. Let's take another example. Okay, another example is, suppose Ben starts a company in which he incurs a fixed cost of 1,250 per month, pesos or dollar, it's up to you, or the money where you live, the currency where you live, for the overhead, which includes his office rent. His production costs are $37.50 per item, Write a linear function C where C of x is the cost for x items produced in a given month. So as you can see here now, C of x. Sometimes it is very, very important that you write your function according to what you are looking for. For example, cost. Then it is better to write C of x, not y. If you are looking for income, then you will write I of x. When you're looking for volume, then it is good to have V of x, something like that. And then we have the cost is 37.50 per item, and fixed cost of $1,250. Then we are finished with that. Our third example. Marcus currently has 200 songs in his music collection. Every month, he adds 50 new songs. Write a formula for the number of songs n. So n, how could I give you n of x as a function of time, n of t, like that, as a function of time, the number of months. How many songs will he own in a year? So we have 50 new songs every year, every month, and he has already 200. So when in a year, 12. We have 15 times 12 plus 200. 150 plus 30. 180 plus 200. 380 songs. N of 12. Next example is working as an insurance salesperson. Ilya earns a base salary plus a commission on each new policy. Therefore, Ilya's weekly income I depends on the number of new policies n. I sub n. I of n. He sells during the week. Last week he sold 3 new policies. 3 new policies. And earned $760 for the week. So we have 3 new policies, 760. The week before, he sold 5 new policies, $920. Find an equation for I sub n, as we'll put here, and interpret the meaning of the components of the equation. Let's see. So our m is equal to 920 minus 760 divided by 5 minus 3. Then we have 0, 6, 160 divided by 2, I hope. 0, 12, carry 1. Yeah. Then I have $80 per policy. Okay. And then we have our y, I sub n is equal to m n plus b. So we're going to solve for b. M is 80 multiplied by n. If we're going to use this point, then we have 3 plus b. Then we have 760. 240 plus b, 760. So if we subtract both sides of the equation by 240, This is 0. Our B here is 0 to 520. Then we have I sub n. Here I have 80 n plus 520 dollars. Find the equation for we found already and interpret the meaning of the components of the equation. So every policy he earns 80 and a base salary of 520. So $520 is the policy and the base salary, and then every policy that he sells, he will get $80. I hope you learned something from the applications, and in my next video lecture will be about parallel lines and perpendicular lines, how we can find or what is the characteristic of a perpendicular lines and parallel lines, and how we can find the parallel lines if we know the function or the equation of one line, and vice versa. I hope you will be there when I will make the video lectures on parallel lines and perpendicular lines.